Welcome. This is Dr. Ralph Esposito. As we move forward, we get through the SNPs and then we get to the macros. And this is a really important area that I would advise the practitioner to pay a lot of attention to, because this is what patients understand. This is what clients understand. This is what the layperson understands. People understand what a gene is. Very rarely do they understand what a SNP is. And they certainly understand that a reduced MTHFR activity with your education on what MTHFR is has some health implications for them. So something that they can actually take from this and understand exactly what their SNPs are telling them. And you can see here that several other applications in the genomic field right now are only looking at MTHFR. Or we can even just do blood work and check for MTHFR, such as 1298C or 677T. However, what we look at here is two genes, CBS and MTHFR. And we saw above that CBS is actually functioning okay. And now we have information on the MTHFR genes, which we're looking at these three particular SNPs. And from this data, the program would automatically curate for you and calculate what the activity of the MTHFR gene will be. And we can see here, based on the 677T and 1298C, that we have a heterozygous and then a homozygous. So there's a 30 to 40% reduced enzyme activity of the MTHFR gene for this particular patient. Another way to look at this is they have 60 to 70% normal activity. So based on their allostatic load and what other factors might be impacting the function of this particular gene, you can then determine how aggressive you want to be in correcting this. If the patient is not showing any manifestations of MTHFR reduced activity, such as high homocysteine levels, inability to methylate certain estrogen metabolites, or even low B12 levels, which although may not be directly related to MTHFR, you want to keep this in context of the patient's whole epigenetic, epistatic relationships. So this is really up to the practitioner to determine how much they actually want to intervene here. And it tells the patient these are several things that are impacted by MTHFR. And this is likely because of the elevation in homocysteine, but correcting for MTHFR certainly can help the individual. And then it tells you whether the risk is and the magnitude as to how this has an impact. And because this is actually not too bad for the individual, they only have about a 30 to 40% reduced activity. Based on the research and the SNP data, it'll give you a magnitude of how important this should be. And really, there is no upper or lower limit. It really depends on the context of the individual and based on other algorithms that we're going to be seeing moving forward. And again, it tells you that this is true for the patient. So this is accurate. This is not false, which means this is something that we want to take action on. But these are the ones that are actually false. So the patient does not have polymorphism affecting homocysteine, and they do not have a 50% reduction in biopterin production. So these are some SNPs that you can decide not to include, and some of this might be confusing for some patients. So this is something that you can adjust on the wizard, and you would say include non-risk SNPs, and then you would just click no, and this would not show up in the report. Completely up to the practitioner. Next, we have the network maps. This is actually probably one of my favorite parts